In this video, I'm going to show you how to solve some basic quadratic equations. Let's just talk about what a quadratic is. It's an equation that has an x squared term. So let's just write down an example of the general quadratic, right? You can see there's an x squared term. It's the highest power of x. That's what makes it a quadratic. Now, a quadratic equation might have one solution, two solutions, or it might not have any at all. We don't look at the scenario of no solutions. We're just probably going to have one or two solutions in this video. So let's have a look. We don't always have a quadratic like this. Sometimes they might look just like this. I'm just going to give you an example with some numbers. 2x squared plus 3, where you can see there's no x term there. It's just an x squared and then a constant number c on the end. They might just look like this, where there's actually no bx and there's no c, it's just got an x squared term. In this video, I'm going to show you how to solve quadratic equations. So they are in the form, I'm just going to write an example of a quadratic equation. Here's a quadratic equation. We know it's quadratic because the highest power of x, here's obviously some x's, is 2. So it has an x squared term in it. So that means it's called a quadratic. It's a fancy name for this kind of equation. And when we're solving, it's equal to something because an equation has an equal sign. And in this case, we're always going to be solving when it's equal to 0. So what we want to do is find out how do we solve something like this. And we're going to start off with quadratics that look a little bit smaller than this, so haven't got as many terms. So for example, I'm going to just start by solving quadratics in the form ax squared plus c. Okay, so we're missing out this term. Obviously, I'm just using any letter there, any constant letter there, but they just represent numbers. So let's do one. Let's do an example. I'm going to go 2x squared minus 18 equals 0. And what solving means is find the value of x for this that works. So we might have 0 solutions, there could be one solution, or there could be two solutions, and that's what we're going to look at now. So what we're trying to do with this is find x, and we can see that there's various other terms that we need to deal with first before we can isolate the x to solve. So I'm going to add 18 to both sides, so we'll just write add 18, and we're left on this side with 2x squared equals 18. Need to divide by 2. Dividing by 2 gives me x squared equals 9. Now, the last step is to find x on its own. I need to do what we call the inverse of squaring, which is square rooting. So I need to square root x and square root 9. So square rooting both sides, square root sign looks like that. When we square root something, we actually get two numbers. We get plus 3 or minus 3. There's two answers. And the reason for that is because if I square 3, I get 9. But if I square minus 3, I also get 9. So there could be two possible solutions here, two possible values that x can take that would work for this equation. And we can check that. We can just show that we get 0 when we sub either of these into this equation. Let's try it. Let's put positive 3 in there. Let's do it now. 2 times 3 squared minus 18. Let's see what we get. 3 squared is 9. 9 times 2 is 18. 18 take away 18 is 0. Verified. Let's now try when it's minus 3. 2 times minus 3. I don't know if I'm on the right at the bottom of the screen now. You can just see it. Let's try it. Minus 3 squared is 9. 9 times 2 is 18. 18 take away 18 is 0. Verified. So you can see we have two solutions to this equation. I'm just going to clear some space. All right, I'm going to do another one now. X squared minus 36 equals 0. Okay, so I've got to isolate the x. That's what we're trying to find. So I'm going to add 36 to both sides, and I get x squared equals 36. Remember, I want to find x on its own. I need to square root both sides, leaving x on the left. Square root of 36 is 6, but not just 6. It could be minus 6 as well. Remember, when we square root something, two answers. All right, one more. Let's look at another one. 3 times x plus 2 all squared equals 27. Okay, so we're going to try and solve this type of equation. So we want to isolate the x, and x is currently in a bracket at the moment. So I'm going to divide by 3 first. Dividing by 3 leaves me with the bracket. Remember, the bracket has a power, so we'll have to leave that in. 27 divided by the 3 gives me 9. Now, I need to isolate the x, so I'm going to need to do that square root here because I need to get x on its own, and that's obviously on the outside of the bracket. Square root both sides. On the left leaves me with x plus 2, and on the right I get the square root of 9, which of course is 3 or minus 3. Now, to show, we don't actually write it like that. Sometimes we write it as plus or minus 3, which I'll show you a little bit later. But I still now need to take away 2 from both sides. But I have 2 possible answers. So I'm just going to move over here. I've got x plus 2 either equals 3 to solve. So we're looking at this one first. And then the next one I need to solve is x plus 2 equals minus 3. So I have to solve both to find out what the 2 values of x are. So I'm going to take away 2 on this one to leave x. So that gives me x equals 1, because 3 take away 2 is 1. And on this one, I'm going to take away 2, and I'm left with minus 3 minus 2 is minus 5. So my 2 values of x are 1 and minus 5. And again, I can verify that by putting them in here. Let's just try one of them. Let's try 1. 1 plus 2 is 3. 3 squared is 9. 9 times 3 is 27. Checked. Verified. And that's pretty much the first part of what I need you to be working through today.